In general, an intracellular protein to be considered effective or functional should be in the range of concentration of 100 micromolar. So this large M stands for molar unit. And what does this mean? How many molecules inside a cell? First, what is this 1 molar? So 1 molar is 1 mole per liter. And we know that this 1 mole is 6 times 10 to the power of 23 molecules. Actually, you can have atoms or ions, other discrete entities. But we are talking about protein now, so we use this unit molecule. Molecules per liter. You might know that this is Avogadro's number. Okay, that's 1 molar. This 100 micromolar is 10 squared times, which is 100. Because of this microunit, we have 10 to the power of negative 6 molar. Since 1 molar is this number here, we have 6 times 10 to the power of 23 molecules per liter. And this is 6 times 10 to minus 6 plus 23. So that's 19. 19, so 10 to the power of 19 molecules per liter. But we are interested in cell volume, not 1 liter, right? So we need to do some conversion. So far we have 100 micromolar, which is 6 times 10 to the power of 19 molecules per liter. Let's think about cell volume. So single cell volume, and we will assume that our cell looks like this, just to make our computation a little bit easy. Typically, a human cell has this size from 10 micrometer to 100 micrometer across. Our cell has 10 micrometer length and 10 micrometer width and 10 micrometer height. Then what is this volume? Now the cell volume is 10 micrometer times 10 micrometer times 10 micrometer, which is 10 times 10 to the power of negative 6 because of this micro symbol. Meter times 10 times 10 to the negative 6 meter. Let me put parentheses just to make things more clear. Times 10 times 10 to the negative 6 meter, which is equal to 10. So this is 1, this is 1, this is 1. If you add all these exponents, we get negative 15, right? And our unit is cubic meter. So that's 1 cell volume, 10 to the power of negative 15 cubic meter. So far we have 100 micromolar equals 6 times 10 to the power of 19 molecules per liter. And 1 cell volume is equal to 10 to the power of negative 15 cubic meter. Now the goal is to represent this concentration in terms of molecules and not liter, but cell volume. So that's what we want to do now. 1 liter is equal to 10 centimeter times 10 centimeter times 10 centimeter, which is equal to 10 to the power of minus 1 meter times 10 to the power of minus 1 meter, 10 to the power of minus 1 meter, which is equal to 10 to the power of minus 3 cubic meter. And that can be written as 10 to the power of 12 times 10 to the power of negative 15 cubic meter. If you add 12 and negative 15, you get negative 3, right? So this number and this number are the same. The reason we have this representation is that this volume is a cell volume, as you can see here. So we can say this is equal to 10 to the power of 12 cell volume. What does this mean? This means that in 1 liter of volume, there can be this many cells. So finally, we want to represent 10 micromolar in terms of molecules and cell volume. So this is equal to 6 times 10 to the power of 19 molecules per liter. And this is equal to 6 times 10 to the power of 19 molecules divided by, so this is 1 liter, and we know that that's equal to this number, right? So we have 10 to the power of 12 cell volume. This is equal to 6 times 10 to the power of 7 molecules per cell volume. So if you say the protein concentration is 100 micromolar, it means that there are 60 million protein molecules within the cell.